Hi class. A few people have been asking me about homework question number 24, so I thought I'd go ahead and make a brief video for you guys. So in this problem we're told that there's a skier who has found a nice flat part of the slope, and as he slides along he travels a distance of 24.3 meters, or whatever your distance may be, okay? And there's a coefficient of friction between the snow and the skis. It's relatively small, but it's still non-zero, of somewhere around 0.5. And you're asked to determine what the initial speed the skier had before sliding this distance and coming to a rest. So since we know he comes to a rest, that it tells us that the final velocity that he has is equal to 0 meters per second. So at first glance this problem looks like there's really not all that much information, and it seems a little confusing. And so the key to solving this problem is considering the work-energy theorem that we just learned at the very end of last class. So the work-energy theorem tells us that the change in kinetic energy in a system is going to be equal to the work done on that system. In this case we have a person who's experiencing a change in kinetic energy. Again, change in kinetic energy is kinetic energy final minus kinetic energy initial. He's experiencing some change in kinetic energy, and that's going to be equal to the work done on him by any outside forces. So I'm hoping you guys can figure out the change in kinetic energy, since we know his final velocity and we're looking for his initial velocity. In case we need a reminder from last class, kinetic energy is equal to 1/2 mass times velocity squared. Okay, and then work, if we remember, is equal to force parallel multiplied by distance. In this case, the force we have acting on the skier is the force of friction, and it's acting in the opposite direction of his displacement d. So our force is going to be negative force of kinetic friction multiplied by the distance d. So if we set our work equal to our change in kinetic energy, we hopefully can try to solve for his initial velocity. Go ahead and give that a shot and let me know if you have any additional questions.